Statue of Liberty was a gift for the United States by the French commemorating our alliance during the American Revolution, and since that day, this copper sculpture has resided in New York City. However, when the United States received it, the statue was not the iconic teal color it is today. Over the course of the next 30 years, the statue mutated from its original dull brown color to the green color we see today. So the question had to be asked, can the color of the Statue of Liberty be achieved in a couple of weeks? The experiment design has two independent variables, the amount of salt and temperature, where we would observe the dependent variable, which would be the change in copper patina. The constants for this experiment include the type of salt, the concentration of vinegar, and the normal color of a copper coin. The three control trials for this experiment are the trial in room temperature, 38 degrees Fahrenheit and 1 degree Fahrenheit, all with no salt. The other 6 experimental trials take place in the 3 different temperatures, room temperature, 38 degrees Fahrenheit and 1 degree Fahrenheit, where each of them have one trial with 1/2 tablespoon of salt and one trial with 1 tablespoon of salt. The materials and equipment necessary for this lab include 9 pennies, salt, vinegar, a 1/2 tablespoon, a single tablespoon, a fridge, 3 cups, 9 Ziploc bags, and 9 napkins. This video is outlining the procedure necessary to create one trial for the experiment. We take a napkin and then we would measure out 1 tablespoon of vinegar and then pour that on top of the napkin and then later place a penny on it. Then we'd place it inside the Ziploc bag, creating an environment where no external factors can really influence our experiment. Now, what we would do after is that this would be one trial with 1 tablespoon of vinegar and no tablespoon of salt. But say we wanted to create a trial with 1/2 tablespoon of salt. We just measure out 1/2 tablespoon of salt, we open up our Ziploc bag, and then we pour it on top of the penny and the Ziploc bag. In total, we would have to create 3 sets of 3 trials, one with no salt, one with 1/2 tablespoon of salt, and one with 1 tablespoon of salt, and then put these in our respective temperatures. After letting the experiment run for a week and taking observations daily, I began to notice a trend in the change in copper patina. And this trend can be categorized through my claim that adding salt to the pennies and placing the pennies in a warm environment relative to colder ones results in a trend of more change from its original appearance. But adding more than 1/2 tablespoon of salt to the pennies actually can cause less change. When we look at the photos of the observations from day 1, we see the room temperature and the 38 degree Fahrenheit and in addition the 1 degree Fahrenheit freezer one all look very similar with no real changes to the copper color on their exterior. By day 2, we see significant changes in the coin. Just in the room temperature trial, we see the most amount of change with 0 salt having a little bit of rusting and turning of brown. Meanwhile, the 1 salt trial has a lot of blue covering the top in bits and pieces, and then we see the 1/2 trial which has almost the sides completely covered. However, in the 38 degrees Fahrenheit trial, we see the no salt one has a little bit of blue patina on its top, the 1 salt one has a little bit too, but then the 1/2 salt one is leading by a large margin here. In the 1 degree Fahrenheit environment, we see the no salt one has little to no change at all. The 1 salt trial has a little bit of blue with 2 dots, but the 1/2 salt trial has the most progress, with the sides being covered in blue. By day 5, we see significant change in the room temperature trials, and this is the group of trials that actually has the most change. The 0 salt trial has a little bit of white forming on top of it, and it's also turned more of a brown color. The 1/2 salt trial is leading with the most dark blue covering it, followed by the 1 salt trial, which has a lot of dark blue covering the top as well, but it's not as bright in color. In the 38 degree Fahrenheit environment, we see the no salt trial has a little bit of blue around the edge, but not very much on top. Meanwhile, the 1 salt trial has blue on top, and finally we have the 1/2 salt trial, which has blue on the sides and dots on the top as well. Finally, in the 1 degree Fahrenheit environment, we see that the zero salt trial in the far back has very little to no blue color on its top. Meanwhile, we have the 1 salt trial, which has two reasonably sized dots there, and then the half salt trial is leading with a lot of the edge being covered. Finally, on the last day, day 7, we see the most difference in between all the trials. In the room temperature zero salt trial, we have more white on top of the copper coin, and it's turning more of a dull brown. Meanwhile, on the 1 salt, we have a little bit of blue, and we have a lot of brown covering it. And finally, on the half salt one, we have the most amount of blue patina covering the top of the coin. In the 38 degree Fahrenheit environment, we see the zero salt in the middle, which has a little bit of blue around the sides and a tiny bit on the edge on the top. We have the 1 salt one, which has blue on the top and a little bit on the side, but then we finally see the half salt one that's leading ahead in this temperature, with the sides and most of the top being completely covered. Finally, in the 1 degree Fahrenheit environment, we see the no salt trial in the very far back with a little bit to no blue patina. Meanwhile, we have the 1 salt trial with 2 to 3 big dots on the top. Finally, leading with the half salt trial with the sides completely covered and the blue patina working its way into the middle. So, to summarize our findings from this experiment that support our claim is that to increase the amount of copper patina and to create the penny to have this blue effect, what we would do is we increase the temperature, and having it in a warmer temperature seems to allow more of this change in color to occur. In addition, increasing the salt does also increase the amount of color change of the penny. However, that salt amount has to be less than half a tablespoon of salt. Otherwise, it seems to have a negative effect on the formation of color on the penny. These observations allow me to confidently state that the validity of my claim is in fact very strong.